Assalamu alaikum. Bismillah ar-Rahman ar-Rahim. In this video, I will try to solve all the exam questions from section 2.2. So let me remind you what is this section about. So it is about graphing functions. So here we will try to answer some questions based on graphing. So how to test a function when you are given graphs, or if you are not given graphs, and also how to find the value of some piecewise functions at some specific values. Okay, so how to find the value of the function at some specific values, how to test the function. Maybe you are given graph or you are given relations. So we will answer maybe only these two questions. We will start with this exam question. It was in 2.2. We are given here f, which is piecewise function. We need to find f at minus pi plus f at 1 plus f at 4. So look here, our job is to find the value of f at some specific real numbers. So here you have to know where is your points, or where is your number. For example, minus pi. Where is minus pi? So for example here, our function is this one, less than or equals to minus 1. This is minus 1, for example. Between minus 1 and 2, and bigger than 2. So the function bigger than 2 is 3. The function of x, this is x. So here, this is x. And here, this is x, and this is x. So the function or the value here, f is 3 for any x. For no, I think it is not working. But anyway, you can understand like this one. And if x between minus 1 and 2, our function is absolute value. And if x less than or equals to minus 1, it is the so-called greatest integer function. Time. Now, where is our pi? Minus pi. Our minus pi, it is our minus pi is here. So minus pi, it is in this interval, and 1 is here, and 2 is here. Right. So we can find what is f at minus pi. Right. So let me show you here. First, I will find f at minus pi. Look here, it is minus pi, not pi. F minus pi, or f at minus pi, or we can read it f of minus pi. So this will be, since minus pi is in the first part, it is here, then it will be greatest to pi minus 2 pi plus 6. Now we know that 2 pi is around 6.28. Then this approximately will be minus 6.28 plus 6 from the question. Now when you subtract, you will have minus 0.28 inside greatest integer function, and this will be minus 1, because you know that. Let me draw a line to understand this one. For example, this is the real numbers line. This is minus 2. This is minus 1, and this is 0, for example. Where is your number? So our number minus 0.28, it is here. Minus, for example, minus 0.28. Then the greatest integer number less than or equals to this number is minus 1. Now this is f of minus pi. Now we need f at 1. Of course, the others are easy. So this is the most important one. And the question is based on this point. Do you know how to find the value of greatest integer or no? F at 1, it is absolute value of 3 times 1 minus 4. It is absolute value of 3 minus 4, which is minus 1. And we know that greatest of minus 1 is 1. Finally, f at 4, so it is the last part, it is 3. It is a constant. So it is, we call it a constant function. Constant, it means for any real number bigger than 2, so the value is 3. It is constant. نفس الشيء ثابتة. Now we will add. So now the answer, f at minus pi plus f at 1 plus f at 4 is going to be what? F at minus 1 is minus 1 plus 1 plus 3. The answer is 3. The answer is 3. So another question which is similar. So we will answer only like these questions and how to test the function if you are given relations, not graphs. So here we need to find f at pi minus f at minus 2. First you have to know where is your pi. Our pi is 3 point something, so it is here. Our pi is here. Now we will replace every x by pi. Then f at pi, it is 3 pi minus 4 inside greatest integer function. And this will be around what? You know that we need to find what's 3 pi. So we try to multiply 3 by 3, 14. So it will be 3 by 4 is 12. Then this will be 4, and this is 9. And we have to, the decimal sign is after 2 places. So it is 9.42. When you, so it will be 9.42 minus 4. And this will be 5.42. And the greatest of 5 point something, it is what? It is 5. It is what? It is 5, because you know that this is 5. Yeah, this is 6. So 5 point something, it is here. So the greatest integer less than, يعني أصغر عدد أكبر عدد صحيح أصغر من هذا, it is إيش? It is 5. Now the second one, f at minus 2. F at minus 2 is equal to, so do not take minus outside. No, we don't know is it even or no, so do not touch this one. Do not do this one. F at minus 2, where is minus 2? Minus 2 is between minus 3 and 1. Then replace every x by minus 2. So it is going to be what? Absolute value of 2. When you put x minus 2, so it will be 2 minus 10. And it is minus 8 inside absolute value. And we know that absolute value of minus 8 is 8. Finally, if خلاص, we need just to subtract. We need to subtract. Then f at pi minus f at minus 2, it will be 5 minus 8 which equals to -3. Solve one more. So all these questions in this section similar to this one. Piecewise function, one branch or one part is absolute value, and the other is what is greatest integer function. Type here, f of x. Of course, here it is fine, but if you like, we can rewrite this one to be more clear. The first part is absolute value of 1 minus 5x. You know that if you have any quantity to the power 2 inside square root, so this will give you what? Absolute value of that quantity. Like the other one is 2x plus 1, greatest integer function. This one if x less than 2, and this one if x bigger than or equals to 2. Like now we need f at pi, so f at pi is equal to. So first you have to decide where is your pi. So our pi is here. Our pi is in the second branch. Then we substitute or replace every x by pi. It will be greatest of 2 pi plus 1. So we approximate this quantity. We know that 2 pi is approximately 6.28. Then 6.28 plus 1, it will be 7.28. And we know that the greatest of 7 point something, it is what? It is 7. Finally, f at 1. Then we add f at 1. Of course, 1, it is less than 2. It is in the first part. So 1 is here. It is less than 2. We replace every x by 1. It will be absolute value of 1 minus 5. And it is going to be what? Absolute value of negative 4. And it is what? It is 4. Now when you add 7 plus 4, the answer is what? The answer is 11. So then f at pi plus f at 1 is equal to 11. This question is about, let me solve one more. We will solve all these questions. Then we will come to the second part about how to test functions. So here we are given piecewise function, absolute value, and the greatest integer function. We need to find f at some specific numbers. So we start with f at -2. So where is -2? It is in the first part because -2 is there. So -2 is less than 0. Now when you substitute every x by -2, then this will be minus 2. And absolute value of 2 is 2. So the answer here is what? Is -2. F at 0. Where is 0? F at 0. So 0 is here. Look at this equality here. Then f at 0 is -2. And f at 2 pi is equal to, so 2 pi, it is 6 point something. It is bigger than 4. So 2 pi is here. 2 pi is bigger than or equals to 4. So we replace every x by 2 pi, then it will be 2 pi minus 4 inside the greatest integer function. This will be approximately 6.28 minus 4 inside the greatest integer function. And when you subtract, we will have 2.28. The greatest integer of any number bigger than, I mean between bigger than or equals to 2 less than 3, it is 2. Now we just add 2. We have here 2. We have here -2. When you add, you will get 0. When you add 2 minus 2, so the sum or the total of the sum is what is -2. Then The answer is f at -2 plus f at 0 plus f at 2 pi. So the sum is -2. This question also, we are given piecewise function. We need f at -2, f at pi, f at 5. So first, where is -2? So -2 is here. -2 is less than -1. Then f at -2 is only -3. Type f at pi. F at pi. Where is pi? Pi is 3 point something. So pi, it is here. Pi, it is here between -1 and 4. So it will be 2 pi -2. So the same or similar to the above question. So this will or can be approximated by 6.28 minus 2. And this will be 4.28 or the greatest of 4 point something. And we know that it is what? It is 4. Finally, f at 5. So 5 is here. 5 is bigger than or equals to 4. It will be absolute value of 3 minus 5. Absolute value of -2. And we know it is +2. Now we add 2 with 4 is 6. 6 minus 3 is 3. So the answer is f at -2 plus f at pi plus f at 5 is is 3. 4 plus 2 is 6. 6 minus 3 is 3. This question is similar. We need to find f at -1, f at 0, f at pi. So, for example, here we start with f at -1. So where is -1? -1 is here. So -1 is less than or equals to -1. So it is -2. Type the second is what is f at 0? And f at 0 is equal to, where is 0? 0 is between, so 0 is here, between -1 and 1. So f at 0, just put x0 or replace every x by 0. When you put 0, you will have only what? You will have only 1. Finally, f at pi. F at pi. Pi is 3 point something. It is here. So pi is bigger than 1. Then replace every x by pi. Then approximate this quantity. You know that pi is 3.14 minus 1. It is 2.14, for example. And the greatest of 2.1 is equal to 2. Now we have 3 numbers or 3 values, this one, and this one. So we ask about the sum. So the answer is f at -1 plus f at 0 plus f at pi. So the total sum is 1. One question or one more question. So I will give you some minutes to have a look here. Similar. So we need f at pi. Where is pi? Pi is here. Pi bigger than 0. And -half is less than or equals to 0. So f at pi is equal to pi -1 inside greatest integer function. This can be approximated by 3.14 minus 1. and greatest of 2.14 is 2. Now if at minus half, so we replace every x by minus half, it will be 2 times minus half minus 5, all inside absolute value. So it's going to be what? Minus 1 minus 5, which is absolute value of negative 6. And it should be what? It should be 6. Now we need to subtract 2 minus 6. So the answer is minus 4. Then f at pi minus f at minus half, it will be 2 minus 6. And the answer is what? Is minus 4. So do not take the minus outside. Do not take the minus outside. It is a big mistake because we don't know is it odd or not. This is the last question of these types about greatest integer, about piecewise, about whatever. So here he said f of x equals to x minus greatest integer of x. Find the value of f at 5 over 2. So f at 5 over 2, it will be 5 over 2 as it is minus greatest 5 over 2. This can be simplified into 5 over 2 minus greatest 2.5. And it is going to be what? 5 over 2 minus, what is the greatest of 2.5? It is 2. Then 5 over 2 is 2 and half minus 2. So the answer is half. The answer is half. This is the last question of these types. So this section is too short. Now we will solve questions about like this, how to test the relations, or how to check which one is a function. So you know that if you are given graph, we apply vertical line test. If you are not given graph, we use these remarks. So what are these remarks? How to write these remarks? So any relation or any equation has one of the following. It is not a function. So here, let me write the following. The following cases are not functions. Of course, function y as a function of x. We consider now y is a function of x. If you switch, something will be different. So y, be careful about this one. It is important. Y, it is a function or a function of x. Type. What are these cases? Number one, vertical lines are not functions. So number two, if the first component is repeated, so it is not a function. So I will repeat those cases with not, or they are not functions. So we mean that by first component, if you are given like the case in E, if you are given a set of ordered pairs, 3, if your equation or relation involves absolute value of y, if we have absolute value of y, absolute value of y minus 1, absolute value, so absolute value of y. And also, we know that y squared inside the root, so it is absolute value of y. And y plus 1 or 2y plus 1, all these. So if you have absolute value of y, or the term, the y term is inside absolute value. Number four, if you have y to the power 2 or y to the power 4 or y to even number, not only y, the y term, maybe you will have y minus 1 squared, maybe y minus 2 to the power 4, and etc. Of course, without conditions, and sometimes when you have some conditions, so we will see some examples. So here we have vertical lines, we have first component is repeated. We have, yeah, I think they are maybe number 5, when you have y is equal to plus minus. So it is the same as absolute value of x when you have y equals to plus minus something. So those are not functions. So for example, here in this question, he said, which one is a function? So e is a function. Why e? We need to check the first component repeated or not. So for example, here, 2 not repeated, 3 not repeated, 4 not repeated, 5 is not repeated. So it is a function. D, why it is not a function? Because we have absolute value of 1. C, why it is not a function? Because y to the power 4. B, why it is not a function? Because you have y plus minus positive. And A, why it is not? Because this 3 and 3 are repeated. So no need to graph, just only use this or this remark. Maybe I will. Look at this question, which one is a function? If you look at E, E is a vertical line. So E is a vertical line. It is not a function. If you look at D, the first component 2 is repeated. It is not a function. If you look at C, we have y squared. It's not a function. If you look at B, we have y squared. It's not a function. If you look at A, we don't have absolute value of y. We don't have y squared. We don't have, so it is a function. It will be y equals to minus 5 over x. If you look at this one, yeah, it is similar to. So for example, the first one is a vertical line. The second one is not a function because we have y squared. The third one, or C, is not a function because 2 is repeated, first component. And the last one, E, is not a function because we have y squared. D is a function because you can write y as minus 6 over x. We don't have absolute value of y. We don't have y squared. Look at this one. Similar questions. Which one is a function? So we use this remark. Ya is not because we have y squared. Yb is not because we have y squared. Yc is not because we have absolute value of y. Yd is a function because the absolute value is over x, not over y. Ye is not because is x equals to 1 is a vertical line. So here, this one, it is a little bit, so you know that we have absolute value of y. The relation y, absolute value of y equals to x is a function f. We know that absolute value of y equals to x is not a function for sure, because we have absolute value of y. But you know that absolute value of y, if you take the positive one, y equals to x, or if you take the negative y minus y is equal to x, so those are functions. هذول يعتبروش functions. طيب here he said which one, I mean it is a function if x bigger than 0, if x, so look here, if y bigger than 0. لو كان y bigger than 0, we will have this one. and it is what? It is a function. Let me graph this function or remind you the graph of this one. Maybe from the graph you can understand more. The greatest integer, I'm sorry, absolute value of y, it will be like this. So this is absolute value of y is equal to x. And you know that the other one, if you have y is absolute value of x, so that one is like this. Okay, it is a function. That one is a function. Like this one is not a function, but if you take, for example, here, he said if x bigger than 0. Like if x bigger than 0, this one, it is if x bigger than 0. So here, if x bigger than 0, this one. It is not a function. If x between 0 and 4, يعني ناخذ الجراف بس between 0 and 4, is still not function if you apply vertical line test. If you take y less than 4, so y less than 4, it means we can take the graph from here to down, which is not a function still. If you take y bigger than -1, so y bigger than -1 here, it is similar to y less than 4. So we will start from here. مثلا هنا y bigger than -1 from here. Just only to remove this part, which is not a function. But if you take only y bigger than 0, you know that here y is positive and here y is negative. So here y is bigger than 0 and here y less than 0. So y bigger than 0, we will take the upper part and we will remove the lower part. Now, for sure, it is what? It is a it is it is a function. It is a function. Okay, I think this is the last. Yeah, still here. Here, which one is? So let me take a copy of these properties or these remarks. Okay, so let us discuss. I will discuss with you why a is a function, because we don't have absolute value over y. Why b is not a function. It is a vertical line. A vertical line is not a function. C, it is not a function because we have absolute value of y. D, we don't have absolute value of y, but we have this one. So you know that root y squared, it is what? It is absolute value of y. E, we have y squared. So the only one which is a function is given in A. Oh, it is repeated or repeat this question. Right, I will discuss with you why he said which one does not represent a function, represent y as a function of x. طيب الأولى ليش هي function? Because the absolute value is over x. B is a function because the square is over x. C, it is a linear function. It is a function. D, it is not a function because absolute value over y. And finally, E is a function because we have y cubed. We don't have y squared. We don't have absolute value over y. I think this one, I hope it is the last because they are repetition. Yes. So that is it. I will stop recording here. So this section 2.2 is very short, is mainly about these two questions, how to test the function by using this remark, and also how to find the value of piecewise functions at some specific numbers. I will stop recording. Thank you.